Hello everyone, it's March the 5th. I just finished the contest. Surprising. It took me, I think a not even an hour. It took me 43 minutes, I think. But, question number two, I had two wrong submissions. So that added 10 more minutes to my total. So I think our total minutes is 53, right? 53. Now, the fourth question, usually the fourth question is the hardest, but this time the fourth question, actually it's easier than, I won't say than the second. All of them are pretty easy, right? All of them pretty easy. Um, but like the first one, it's easy, but it's kind of a complex, right? The second one is just I used a slow method at the beginning. I thought I would be able just to get by, but I did not, so I have to use a little bit smarter. And then I made just a silly mistake. I forgot to handle the duplicates, and then I got so the time limit exceed. That was the first error, and the second one is because I forgot to handle the duplicate. So I got two errors. The third one is a binary tree. Now, as you guys know, I love binary tree, so it's not too big an issue. But I do feel my way of solving it is a little bit stupid. So I think after the contest is over, I'm gonna take a look at number three and just kind of see how smart people do it. Now, number four is actually very easy. Although it's labeled as difficult, it's not. It's not difficult at all. It's straightforward, very straightforward. Yeah, so I check my temporary ranking, and then from the ranking you can see I solved all four in, I mean, the official time is 53. I rank 1,111, I think, the last time I checked. I'll check again after the contest is over, but this is ridiculous. So many smart people out there, all right? So many smart people, and um, it's just like because I lift, right? I lift, and I look at people really good at lifting weights, and it's just outrageous, right? Just outrageous. I call myself mediocre, but sometimes I feel like I don't even reach the level of mediocrity, right? Mediocre at my body weight shall do, I don't know, maybe what, uh, 100 kilo snatch and maybe 130, right? 100 kilo snatch and 130 to 135 clean and jerk. I think that is mediocre at my body weight because the elite at my level is 160, all right? 160 snatch and 190 clean and jerk. Right? That's elite. So I haven't even reached 100 snatch yet. Right? My snatch is like 20 kilo off, and my clean and jerk is about actually 30 kilo off. So I'm definitely not even mediocre yet, even though I try to call myself mediocre. Here is the same, right? The same. I had a good performance day, but it's just because everything is easy, so it's got inflated. And you see the ranking is the same. It's just the same. It's mediocre. It's just not even mediocre. So sometimes it's just very frustrating, right? You feel like there gotta be something I'm good at. There gotta be something I am like a top 1%. But no, you are not. Right? You're not. Like physical fitness, I am not. Mental fitness, I am not. Damn. Right? Damn. But it's fine. Right? It's fine. Um, they, there are always people better than you, and it's really difficult to reach the 1% level. But you don't need to be a 1% person to lead a happy life. You find someone who you find friends or find a partner that supports you of what you like to do, and you can earn a good living. Be an honest person, responsible and honest person. That's good enough. That's good enough. Being 1% is always something you should strive for, but sometimes it's you know it's just not it's not easy. It's not easy to be on 1%, but it's fine. Right? It's fine. You acknowledge that it's fine. All right, this is a new problem. Count all valid pickup and delivery options. Ooh. Oh, I hate this type of question. Input is a value, output is a value. So simple, right? But the problem is not simple, I can guarantee you that. Given n orders, each order consists, that should be off, right? Pickup and delivery services. Count all valid pickup delivery possible sequences such that delivery I is always after pickup I. Oh, we need a modulo. N orders, so P1, D1. All valid pickup and delivery such that delivery I is always after pickup I. So P first, D after. So if I go pickup 1, delivery 1 must be after. That's a good question. That's a good question. All right. So basically, we have n pairs, right? P1, P2 all the way to Pn, and D1, D2 all the way to Dn. So the question is, how many different possibilities do we have where when we order all the P's and D's such that Pi is always in front of Di? And it doesn't really matter the P's, right? It doesn't matter. We can do any order within the P's, any order within the D's. All only matters is Pi is in front of Di. Well, n equals 1 is easy. N equals 2. It feels like if you solve n minus 1, you shall be able to solve n plus 1. So let's try that. So n equals 1, right? Which means, right, it doesn't actually mean anything. So just P1 is in front of D1. We know that, right? And P2 in front of D2. Look at n equals 2. So we can say if P1 is the start, all right? And we know n equals 2, there are 4 positions. So 1, 2, 3, 4, we have 4 positions. So we have P1 at the start. Then we need D1, right? If P1 is at the first spot, D1 can be at the second spot, at the third spot, or at the fourth spot, right? If D1 is at the second spot, then we have 2 spots left for P2, which there's only one possibility, which is just, so we have P1, D1, P2, D2, right? That's good. Now if we have P1, empty space, and D1, oh, that's also only just one possibilities, right? So we have P2, so P1, P2, D1, D2. And if D1 is at the last space, then in the middle is the same, P1, P2, and D2. Okay. Then we say P1 is at the second spot. If P1 is the second spot, D1 right after, or P1 empty and then D1. Okay, and P1 and D1 at the end. Okay. Okay, that's 2. Let's keep going further. So we have 2, right? So next target is 3. Hold on, I need a piece of paper. All right, let's draw number 3. Let's say we have 3, and kind of see how n equals 2 can help us. So if we have 3, right? Again, we targeting P1. It's actually we can targeting P3, but it's the same. It's the same. Let's go P1. So we have 3 is 6 spot, right? 1, 2, 3, 4, 5, 6 spot. So you have P1 and D1. So P1, D1, and 4 empty. And isn't that the same problem as n equals to 2? All right, think about it. So just P2, D2, and P3, D3. That is exactly the same as n equals 2. So there are 6 different possibilities, right? So we have 6. And if P1 is the front, we have empty and then D1. Then 1, 2, 3. That's also 6. And then, so D1 can be at a 1, 2, 3, 4, 5. So P1 at the first spot, D1 have 5 different spots, and each one has 6. So that's 5 times 6, plus P1 can be on the second spot. Then D1 can have 4 spots, so it's 4 times 6. And P1 at the third spot. And D1 has 3, so 3 times 6, and then plus, 2 times 6. And plus 1 times 6. Right, so we're looking at 5 plus 4 plus 3 plus 2 plus 1 times 6. Now, 1 to 5 is 15. 15 times 6, 90. 90. All right, let's try. Let's try to see if it's 90. We pass n equals 3. Doesn't matter. Let's just say return 90. I can just return 0. It doesn't matter. So let's say 3. Is it 90? Oh, it's right there. It's right there. Didn't see that. All right, I think we found it, right? Which means we know n1 is 1, right? So if n equals to 2, our formula is a formula is 1 plus, hold on, n equals to 2, we have 4 spots, right? 4 spots. So P can go 3. P can go 3. So it's going to be 1 plus 2 plus 3 times 1. Right? So 1 plus 2 plus 3. 1 plus 2 plus 3 times 1. 1 is when n equals 1. So that's 2. So if n equals 3, we have 6 spots. So we have to go 1 plus 2 all the way plus to 5. Then times n equals 2, which is 6. That gives 90. Let's do one more. N equals 4. Right? N equals 4. We have 8 spots. So we have to do 1 plus 2 all the way to 7. And times 1 n equals 3, which is 90. So 1 plus all the way to 7 times 90. What's 1 plus all the way to 7? That's 8 times 7 divided by 2. That's what? 28. So 28 times 90. I don't know. 28 times, I got my calculator. 2,520. Okay, let's just try. Let's try n equals 4. If that is correct, I'm going to write the solution. 2,520. 2520. Okay, we got this one. Not too bad. It's not too bad. So just write it out. Right, write it out. You'll find the pattern. You'll find a pattern if you write it out. It's always like this. It's always like this. It feels like more math, right? It feels like more math. So all the keys always define a pattern. And we call this, right? Do we call this DP? Yeah, we call this dynamic program. This is DP, right? So, but it's going to be a we don't have to, O1 DP, right? So we know, what do we know? We know n pre, right? Pre equals 1. And then for I don't know, for I in range from 1 to n plus 1, right? We can say pre equals, right? Then we do I times 2, right? I times 2 is the total number of spots minus 1. That's what we have to add to this. So plus 1, right? And then times the total number of items. The total number of items is going to be I times 2 minus 1. Right? And then divide by 2. That's the total sum. Then times pre. And the entire thing, we need to mod. So mod is 10 to the 9th plus 7. So we have to mod every single time. So mod. Okay? And then we return pre. Alright, let's run this. So 1 is 1, 2 is 6, 3 is 90, and 4 is 2,520. And oh, it's also easy to test this. And alright, so we pass all this, and of course I don't have to do this, right? And I don't have to do this. Yeah, run again. Yep. All right, but let's throw in a few more. All right, let's throw in a few more, just to make sure. 5, 6, 7, 8, 9, 10, 500. How about that? Just kind of see if it's going to time out. Yeah, I think we're good. I think we got this one. Wow. This feels exactly like the problem we just solved. I just solved in the contest. The last one on the contest. It's labeled as hard, but it's actually not. Right? It's actually not that hard. All right. Let's write something. This is what LeetCode. What is this one? 1359. Yeah, I kind of feeling like because look at this, the pass rate is 56%. I mean, it's deceiving some of the times because if the question is really hard, then you'll have a high acceptance as well because people just can't solve it and then they just give up and then go for a solution immediately. So the pass rate will be high. But on the other hand, problem like this, the pass rate high. This is not really that hard. We actually see on the solution, people's comments, you can see that they're going to say, oh, this is not hard. But, well, how should I put it? So, just write out, right? Just write out, let's say, n equals 2. Actually, no, n equals 2 would be hard to see. N equals 3. Write out n equals 3 and observe how the result from n equals 2 helps solve n equals 3. Right? And then we realize that once we know n, we can easily solve n plus 1. Thus, this is a typical DP problem and can be solved using in O1 space. Now, to be specific, given any n, there are 2 times n spaces, right, to fill. Now, if we focus on P1 and D1, if we put P1 at the first spot, then D1 has n 2n, right? 2n minus 1, right? 2n minus 1 different spots to take. and for each such spot, the remaining 2n minus 2 spots, right, belong to, actually don't say belong, remaining spots can be, how should I say, remaining two such spots can, the remaining spots are the results of solving problem n minus 1, right? And since we have already solved, since we have already solved n minus 1, then we immediately know that putting P1 at the first spot gives us 2n minus 1 times, let's call it fn minus 1, number of number of sequences, all right? Similarly, we put P1 in the second spot. That gives us 2n minus 2 times fn minus 1, right? Thus, we have the formula fn will equal to 1 plus 2 plus plus 2n minus 1 times fn minus 1. And this can be solved, this can be solved easily with dp. So on, that's on, 39, 75, that's all right. All right, let's see. Recursion. Nah, we don't do this recursion memorization. That can be bottom up. O(n) squared. Is this O(n) squared? It's not O(n) squared. Tabulation. O(n) squared. This is O(n). Permutation. I think this is the one that we have. Yep, O(n). But I think it's slightly different, right? It's slightly different. Probability. Hold on. Ooh, that's interesting. Let's read this one. I'm not interested in the O(n) squared solution. All right, we want to place 4 different objects in some order in a row. What are all the possible ways to do it? Yes, okay. It's the, what's that? Factorial. Total ways of factorial. Permutation. Now, the given problem can be changed to a similar permutation problem. Holy moly, it is. We have n orders, each with a pickup. Let's denote pi, pickup, we have 2n empty positions, yes. Can always place all pi's, yes. So we first place all the n pickups in some random order. That is true, because the pickup order doesn't really matter, right? So we have n factorial ways to place, and then, and then what? Now I start placing all the deliveries. The last pickup, hence these 3 have only one place. So one of them has one place, yes. And for the P1, right? For P1, we have 3 places to place P1 because when put it here, here, or here, I have 3 places. That is correct. For P4, we have after we put about P1, D1. After we put D1, we have a 1, 2, 3, 4, 5. We have 5 places. And then for this one, we 1, 2, 3, 4, 5, 6, 7 places. So that will be, oh my god, this is good. And I still think this one's easier to think about and to write it out, but it's fine. But this is good, right? So if you code it up, permutation is n, right? So we always just times I. Okay, so we always times I. So we make sure that each one we do. Wait, hold on. We can just keep multiplying? Oh, yeah. We just keep multiplying. Because for n, right, for n is 1 times 2 times all the way to n. And then times 1 times 3 times 5 to all the way to 2 and minus 1, right? So you have all this. You find the next one, which is times n plus 1. N times 2n plus 1, right? Times 2n plus. Well, I mean, it's just, yeah, 2n, the next I minus 1, right? So we just times this, and then we take the mod. We can take the mod? Multiplication doesn't matter? No, I don't think it matters. Mod plus, plus a plus b mod something equals a mod this plus b mod this. And multiplication can do mod as well. Deduction can do mod, but division cannot do mod, right? You cannot say a divided by b, the whole thing, mod something, is not equal to a modded divided by b modded. But all the other 3 works. So that's why they can just, basically, they don't really care. They just multiply and then we take a mod. Multiply, take a mod. That's a good solution. That's a very good solution. All right, what's the next one? Probability. What the? Probability? Holy moly. Any more? What the heck? 6 questions in a row. Dynamic programming. I did not. I did the previous 4 of 5. Huh. This week is all dynamic programming. Yeah, see, I told you. People are going to say it's not going to be hard. Permutation DP. All right, let's take a look at the probability. Okay, so however we know this is explanation of probability. Let's define a favorable outcome as a sequence where each PI occurs before DI. That's this problem. Number of arrangements equals probability of arranging n orders in a valid sequence times total number of possible arrangements. Okay, so this one will be 2 times n factorial, and we just need to find the probability. Okay, if I only have 1 order, 2 arrangements, Yeah, that's 2 factorial. Thus the probability to arrange one pickup is 1 over 2. That is correct. If we have n orders and pickup and delivery is reversed for any one of the orders, then the sequence is not valid. That's true. But to have a valid sequence, and we must have all n pairs of Pi and Di in the correct order, where each pair has the probability of 1 over 2 of being in the correct order. That is true. So the probability of arranging n orders in a valid sequence. Oh my god! I need to process this. We have Pi and Di, right? And Pi and Di has 2 orientations, either Pi Di or Di Pi, right? So given a sequence where Pi and Di is in the sequence, the probability, well, given like all possible arrangements, and the probability that Pi and Di is in the correct orientation is freaking 1 over 2. Yeah, it is 1 over 2. It's like flip a coin, right? No matter like the order, like you have, yeah, think of Pi Di as a coin, and you have different coins. Let's just say coin of from different countries, all right? And then you're just flipping them, right? You flip them and say it has to be, each coin has to land on the head, and then you just keep flipping. Doesn't matter the order you flip, doesn't matter. And the end result is each coin has to have the head facing up. And what's the probability for the head facing up for each coin? It's a half. And we want all the coins to be facing up. So that's half times half times half, n times. And then you just times, oh my god. Oh my god. This is so good. This is so good. Yeah, you have to hand, oh my god, you just, this is the computer. Well, of course you cannot do it directly, but, wait, what the hell? What the heck? Oh, 2 times n. Uh-huh. 2 times n. So, like, we don't care. We don't care. 2 times n. So, this gives us the factorial, and we're going to divide the result by 2 n times to prevent decimal results. We divide after multiplying an even number. Hold on. So we need to calculate this divided by 2 to the nth power. Therefore, we will multiply, and every time we hit a even number, we divide it by 2. Which makes sense, right? Because there are 2n of them, right? 2n of them. So we have n even numbers. And we divide by 2 to the n. So each time we hit an even number, we divide it by 2. Makes sense, right? Makes sense. And they can do that. I just said division doesn't work with mod. I don't know, but apparently it works here. Division, I think it has to be mod, right? Let's check mod. Modulo operation. Let's just refresh on the math. I think division can work if the dividend is co-prime, right? Is that a thing? Hold on. Common pitfall, performance, properties. We know identity, inverse distributive division. Yeah, we know this, right? This commonly used. A times B, it works, right? So A times B works, A plus B works, and plus, if plus works, minus also work. Division. A divided by B equals this A mod, basically divide by B mod, right? When the right-hand side is defined, that's when B and N are co-prime. So B and N are co-prime, which means in this case, our B is 2. So 2 and mod, they're co-prime because this is 2. This is an even number, odd number, so they're co-prime. Therefore, it's allowed to do division and then do the mod. Oh my god, this is so good. But a little bit tricky, right? A bit tricky to do the whole operation. You're not going to do factorial for 2 times n. Yeah, you have to calculate. That's just minimum. Yeah, that's going to be a gigantic number. Wow. Wow, good. I mean, yeah, question like this, you say it's easy, right? It's not easy. You say it's a medium problem, but you then come up with all these different solutions. And actually, our solution is different from this, right? Our solution is different from this. But permutation was good. That was a good way of thinking. And the probability was just so nice. So nice. All right, we are half an hour in. Let's try another one. All right, let's do another one. Nah, I'm kind of lazy. Let's do an easy one. Let's do an easy one. Yeah, I'm kind of lazy. It's kind of lazy. Yeah, I'm gonna put update here. So the official solution offers 2 very good solution. 2 very good. I already used solution. The official solution offers 2 very good ways of approaching. All right, approaching this problem. One is via permutation. The other, probability. My God, probability is so good. All right, so yeah, let's do an easy one. I feel. No, I'm not doing these. These are SQL. I don't like SQL problems. All right, let's just do one. So there's always the goal to get to 1,000 problems solved. That would be fun. Oh, actually, we're getting close to the end of the contest. So we can actually go back. I think I have one problem, right? Problem number, not number 2, problem number 3. All right, problem number 3, I want to take another look. That's fine. Let's just solve this one for fun. Contains duplicate number 2. What do you want? What do you want? Given an array and integer k, return true if there are 2 distinct ij's in the array such that I is equal to j, nums I equal to nums j, and absolute value. So the distance between the 2 is smaller than k. Huh. Okay. So the distance. Huh. So we have k, right? So let's say we start from here. K is equal to 3. So the things we need to search for is 1, 2, 3, right? We need to search for this, this, and this to see if there is anything matching. This is stupid, right? Because when you come here, you have to do it again. Then the total runtime will be O(n) times k. And look at this. N is 10 to the 5th. K is 10 to the 5th. That's not going to work. So what we're going to do is we're going to do a hash map. So the key will be each value. and the value will be a list of positions, right? A list of positions, because we're trying to see if it exists. So for each key, we're going through and to see if there are any pairs, right? If there are any pairs that whose distance is smaller or equal to k. And we only need to consider adjacent pairs, because if adjacent pairs is smaller than k, we're done. If adjacent pair is larger than k, then non-adjacent pairs will definitely be even larger than k. Okay, let's try this one. Let's try this solution. 219. See, like, if this idea is correct, I actually think this one is. I will not mark this as an easy one. This is like a medium one, a lower tier. I have solved medium questions easier than this, and easier questions harder than this. Actually, there are. I don't remember. I think there's one easy problem that really troubles me. All right, so we have a hash map, right? Let's call it hash map. No, we can do default dict. All right, so collections. Let's do default dict on this. All right, so we do default dict and list. And we say for I, n in enumerate nums. What do? We do a hash map n dot append I, right? So once we're done, actually no, we can check it right here. We can check it right here. So we appended it, right? And we say, what do we say? If len hash map n, right, is larger than 1, and hash map n minus 1 minus hash map n minus 2 is smaller or equal to k, we return true, right? So basically, every time we add a new index, we check, right? Every time I add a new, because we will do pairwise checking for consecutive pairs anyway. So every time we add a new one, we can check with the previous. And if it's smaller than k, we're done, right? If it's larger than k, that's fine. We can check the next one. And blah, blah, blah. After that, we return false. All right, let's check this. Yeah, I have confidence. I have confidence in this, but let's check. So we have this. So three. This one is a true. Yeah, it's a true. And then this one is also true. And the last one is false. All right. Then let's remove these two. So this one is nums. Okay. Contain nums. Okay. All right. So run this. All right. I think this will work, but a good habit, always try it again. I have so many cases where I forgot to test it and then I got a wrong submission. All right, let's go. Let's try this. Come on. Booyah! 790 milliseconds. What's the runtime? OM. Yeah, that's OM. 790 55. All right. Let's write about it. So what do we say? We say use a hash map to collect the indices of all all repeated values. Yeah, sorry, repeated values, right? And then we just need to check each consecutive pairs of indices of each repeated value, and if any consecutive pair difference is not larger than k, we can return true. In implementation, it is possible to make the check while creating the hash map. Right? This can speed things up a little bit. Right? This can ensure early termination. Right? We don't have to wait for the entire nums to be checked. If like the first two already make sense, then we just only need to do 2 times. All right, let's take a look. Yeah, I'm pretty sure this is the standard solution. Simple Java solution. Hash map. If I is larger than k, set the remove. Wait. What the heck? What the heck is this? It's a hash map. We call it a set, right? And then we go through all the i's, and if I is larger than, what the hell is k? Oh, like what the hell is k? If I is larger than k, okay, then set dot remove nums I minus k minus. That makes sense. If not, set dot add nums I, which means I is. Oh, I see. Sliding window. Oh, beautiful. Beautiful. Let's try this. I think this is sliding window. Yeah, I was thinking about sliding window a little bit, but didn't really implement it. So sliding window. If you think about sliding window, inspired by. If you think about sliding window, this is an easy question then. All right, let's code it ourselves. Let's not look at this. Do not look. All right, how do we do sliding window? We need a set, right? We need a window. W, it's called W, okay? Then, what do we say? We say for in enumerate nums, right? And then, if I is larger than k, right? That means the window is too big. That we need to remove something from inside. We need to remove this. Yeah, so we keep a window of size k. All right, we keep a window of size k, and this window is a set, right? So if the new value we find, we grab the new value, and since we need to grab the new value, we need to remove an old value, so to make sure that the window stays k. But W, the size of W is not necessarily k, right? Because we can have duplicates, so W can be smaller than k. But in terms of the original array, the window is always k. And then we need to grab a new value, so we need to pop one of the value, and then if the new value exists inside this window, that means the difference, the distance between these two values is smaller equal to k. This is so good. Oh my god. So if I is larger than k, right, then W dot remove. Remove what? Nums the one in front of it. So it'd be I minus k. Is that I minus k? So if I is larger than k, let's say I is larger than k. Hold on. I is larger than k. I shall be larger or equal to k, right? Because 0, 1, 2, 3, all the way to k minus 1. That's k, right? That's k. But hold on. Wait, no, not this one. I want, or what is required is this one smaller or equal to k. So I can be 0, j can be k. That still works. Therefore, it has to be larger than k. If it's larger than k plus 1. So if it's k plus 1, I need to remove 0, because 0 and k plus 1 is larger than k. So I, if it's k plus 1 minus k is 1, so we have to minus 1 again. Okay, so we need to remove this, right? And then we say if n is in W, return true. Otherwise, w.add n, and then return false. This is a sliding window. Is this easier? Is this faster? We'll see. I mean, this is on, so we can actually say this is on as well. A little bit, I think it's the same. I think it's the same. I think this is the same. All right, same thing. Okay. See, this is a good question. It's easy, but there are different ways to solve it. And yeah, that's fine. That's fine. Usually that happens. The first time you submit, it's always very fast. And then the second time, always a little bit slower. I don't know, maybe because these operations, add and remove, is slower than append. It's possible. Yeah, but we have a hash map. Yeah, whatever. All right, that'll be it. Good. All right, we did very well. If you think about it, the contest is 4 problems, right? And then this is 2 more. So in total, I got 6. That is a record. I've never done 6 in one sitting. I think, yeah, let's just end it right here. I'm going to read a little bit of one of the contest problems, and if anything interesting, I'll just talk about tomorrow. All right, I will see you guys tomorrow night. Adios.